Okay, so I'm going to start the recording. Okay, so I just wanted to do this one problem here. So first of all, we know what a linked list is. Remember, a linked list has had these node objects, and we're connecting. It's a very important data structure in in like a course like in computer science. Also, I just want to say, so just remember, I don't take attendance. So if some point you need to go, that's fine. I'm going to record the whole lecture. And so in every node, it's kind of like a line. So the first, so we have to start at the first node, which is the head. We know where, so we know where the first node is located. The first node tells me where the second one is located. The second one tells me where the third one's located, and so forth. And when you get to the end, you know you're at the end of the linked list when next is null. And every one of these nodes actually stores some information, because we just don't want to have nodes for the sake of having nodes, right? So maybe they store a string, or maybe they store a lot of information, like maybe an extensive amount of information, but let's say just like maybe just characters like D and Y. But each node stores some information, and then that we can extract. Okay, so here's kind of a fun problem with the linked list, and I don't really ask it in the online classes. I do ask it in the if this is like we were at school at Proctor exam at school. I used to put these kind of problems online on the quizzes and the tests. So let's try this. Let's see if we can predict the output. And so this is kind of fun in a way. So just remember, so students, we see that there's a couple statements in there that say new node. And that's the only time we create a node object. New means allocate memory for a new node object. So just declaring a variable doesn't actually create an actual node in memory. So node R is null. So that variable R can be assigned a node object. But right now it's not actually referring to a real node. Okay, so the first times we have node X right here is node X is new node. So we always start from the right side of an assignment statement. So new node is assigned to node X, meaning new means, okay, so let's allocate memory. Let's allocate computer memory, and then we're going to assign the address of that memory to X. So it's the first time, so here's X. So I always think it's a good idea to draw pictures with linked lists. Oh, then we go X dot item is ABC. So let's put ABC in there. And then we go node Y is assigned new. So we're starting from the right side. So we go new node is assigned to Y. So new node means we're going to allocate memory, allocate computer memory, and then we're going to then assign the address of that memory to Y. And what we put in there is X, Y, Z. Okay, and then we go X dot next is assigned. Okay, so then we're going to go X dot next is assigned Y, or we're going to assign Y to X dot next. So remember, X dot next is the node directly after X. So like we're in line, and X is dot next would be the next one. So we're saying X dot next is going to be Y. So after X, we're going to go to Y. Okay, so we have two nodes now, and we know that after X we get to Y, and now we're going node first is assigned to X right here. Okay, so we're declaring a new node variable, right? But we're assigning it. So remember, X has an address, and we're assigning that address to first. So basically all it's saying is we're going to have two variables. We have these two variables, first and X, and they store the exact same address, right? So it's like two different names for the same object. So if you change X, you're changing first. And if you're changing first, you're changing X. Everything is it's like two people working on the same Word document. One person changes it, the other one's going to see the changes. Okay, so now we have this statement. Node second is assigned first dot next. Okay, so first dot next is assigned to node 6. So remember, first dot next, remember that's the node after first, and it's an address, it's a node object. So we're assigning the address stored in first dot next to second. And what's the one after first? Well, this is what's kind of vaguely interesting about this. We never, look in this code there, you never explicitly assign a value to first dot next. But we did do this. We did say Y is X dot next. We did say the one after X is Y. And first and X reference the exact same node. So first dot next is also Y. And so what we're saying right here is, we're saying that second, this variable second is the node after first. So this would be second. So second is the node after, is first, so second is first dot next, or second is the node after first. Well, the node after, so first and next are the same. So what's the one after x, right? The one after x is y. So the one after first is also y. Okay, so that's pretty wild. Now we're going, oh, look at this. We're going to assign first to r. So the address in first is also going to be stored in r. Oh, so now we have three variables referencing the exact location in memory. The r, first, and x all store the same address. So they all refer to the exact same node object. Okay, so now, we're not done. We're almost done. Second is assigned to first. Okay, so now, the address that's stored in second is now going to be stored in first. So first is no longer going to be referencing that first node. Now first is going to have, the address in first is now going to reference the second node, right? So we changed addresses right there. So first was pointing to the node that contained ABC. Now first is referencing the node object that contains XYZ. But R and X don't change, right? When you change first, we haven't changed R and X. So when I say, before, let me make sure that I didn't make this a little confusing. When I say we change X, we change first, and we change first, we change X. What I think would be more clear to say, when we change the node when we change the instance variables in the object referenced by X, we're changing the instance variables in the object. They reference X first, like here, first and X at this point, reference the exact same object. So you change the instance variables of X, you're changing the instance variables of first, and vice versa. But here we're actually assigning a new address to first, so that doesn't affect R or X at all. Okay, so now let's print out what the contents. So we're printing out r.next.item. Well, R points to that node object that contains ABC, and the one after R is the same as the one after X, right? R and X reference the exact same object, so we're going to print XYZ. And then we're going to print first.item, right? And so first.item also is that node right after, the one after X. So we're going to print XYZ. And then we're going to print r.item. Well, R is pointing to this first node. So that's their answer, XYZ, XYZ, ABC. And I encourage you, it can be hard just watching someone do it, but I would encourage you to try this yourself. Because the one thing about linked list, if you go into, let's say you decide to study computer science and get a 4-year degree, you're definitely going to see this again. That would be my guess. Let's put it this way. I can't say for sure, but it's a very good chance that you'll be taking some class where you work with linked lists. And some of our former students have said that they found it advantageous that, they're taking courses at San Diego State, and linked lists came up and they felt like they had a big advantage because they already knew it. So any questions on this interesting part of the class? So yeah, like I labeled it interesting. Now, students. So all I'm going to do now, of course, I don't have Eclipse open. Let me open Eclipse. Why wasn't I prepared? Okay, so that's not necessarily, I'm more disorganized, that's why. Okay, so let me, okay, where's Eclipse? What happened to Eclipse? Okay, so hold on, students, where's my Eclipse? Okay, Eclipse. I'm going to stop sharing. Okay, so I don't know what happened to my Eclipse. Okay, it should be, what did I do here? Okay, so, oh, I know. I was looking at my browser was covering my window. Okay, so. All right, so Eclipse is opening. Okay, so Okay, I think I actually wrote some of these already. So I am going to, let me just erase some of this. We're gonna go in, we're gonna write these. Okay, so I just will, let's write them from scratch. Okay, instead of just, okay, so do you remember, and I'll put this code online when we're done. So this is the famous linked list code. And if you remember, we know what a linked list is, right? So remember, a linked list is just a chain of node objects. And eventually what I'll do is I'm gonna ask you, I'm gonna add a few methods to linked list class today. And that's all I did in the other class. And then I'll ask you to write a few extra methods for it. But yes, we know what a linked list is. It's just something like this, right? It's just a chain of node objects. It's nothing, I mean, there's really not a lot. So a lot of times students will ask me, they get kind of confused by a linked list. I think part of it is there's really just not that much to it, right? I can describe the whole thing in just a few sentences. It's just the coding that's difficult. It's just a chain of node objects where each node object just has what? Here are the instance variables. Here are the instance variables. Remember the linked list. Well, first of all, we declare that we talked about this before. First of all, it's defined. There's that diamond operator, and that's the generic variable. So we're defining it with generic. So remember that E that's inside the diamond operator. Remember, all that is, it's a placeholder for a class, right? So like when we declare array list in our main method, remember we go array list, and inside the diamond operator, we usually put string. Well, it's that class name that gets passed to E. So if that E is confusing you or throwing you off, wherever you see E, just pretend you see string. And so then we have this private inner class, which I talked about a couple weeks ago, or maybe a week ago. And yeah, we just definitely didn't talk about this in Math 130. And again, the user of our linked list class, all they know, all the user knows, oh, it's storing a collection of data. Just like our array list stores a collection of data. It's like this unlimited collection of data. And we don't really, unless we actually look at the code, underneath an array list is an array, an actual array. There's a private instance variable that's an array. And behind linked list is basically a collection, is this chain of node objects. So the user of linked list doesn't have to know anything about nodes. So that's why we write the node class inside linked list, because the only class that needs to use it is linked list itself. The user, the ordinary user shouldn't, doesn't need to know about the node class at all, unless they're going to do some linked list coding or something. And in this case, and every node just has three. In this case, it's what's called a doubly linked list. We can go in two directions. We can look at the node in front of us and the node behind us. And if all we have is a next property, that's called a singly linked list. But see, the node class itself has very little, 3 instance variables in this case. The item, that's the data we're storing. And then the location of the node in front of us and the location of the node behind us. And that's all there is to a node. And so a linked list is just a collection of these nodes. So I do think one of the reasons why people sometimes get overwhelmed, there's some things in computer science, there's really not a lot to it. And I think we want something to be hard. We're so used to things being hard and a lot of theory behind it. Like in take calculus, there's a lot of theory behind it. So we're just a lot of theory behind what we're doing, but there's really not too much here. Okay, same thing with interfaces. What is it? It's just you define a method header, but it's using it wisely. That's the hard part. And using a linked list wisely is the hard part. Okay, so first let's start with this, what I call this overloaded equals method. And then let's see, I want to talk about set contains, and let's talk about the equals method a little bit later. Let's talk about the set method first. Okay, so you remember in a linked list, we can, like in an array list, we didn't probably use it that much in Math 130. We didn't really talk about array lists a lot. Didn't have time to. But just think of an array list as kind of like an expandable array. And there's a method called set that allows us to change one of the values in the array. And we have the exact same method in linked list. Like most of the methods in array lists are just, we have the exact same methods in linked list. And so the set method would allow you to, here, like, if I did, so like here, this linked list here, I have C, D, Y. So if I went set, like 1, and let's say I put an E, that means go to node 1 and replace that D with an E. And the method, instead, it returns the replaced item. So this set would return D. So what we have to do in linked list is advance to whatever that position is, and then update the item in the node at that position, and then also save the data that we're writing over. So let's see how we could do that. The famous set method. It's very much like get, right? First we have to make, so we can't, so all the nodes are numbered 0 through size -1. So size is the length of the array list, just like size is the length of the linked list, just like size is the length of an array list. And the nodes are numbered 0 through size -1. So we can't we can't change the value of position size itself. So a lot of the set is going to look like it's going to look like get, right? So first, in fact, I'm going to just copy some of this. Most of the first part here can be copied, except we're going to call it set. So whoops. And whoops. Okay, so we're going to update what's at position index with some new data. So first we check. Okay, so we'll give a compiler until we're done. Okay, so first we check on line 37. Are we actually? Is the index within range? So if index is negative, well, it can't have a negative index. An index cannot be greater than or equal to size. There's no node at position size. And so, so if the index is out of range, we just say, or out of the proper range, we say index, we'll throw a new index out of bounds exception, and that can be caught in the main method. The thing is, we should write our, good code would never actually have to throw this kind of exception. So, and then, okay, then we're going to have to iterate through the linked list. So, so remember, once I got, I'll go here. Remember, we started that when we're iterating through the linked list, we have to start at the head. So we start at the head, and then we can, if we iterate every time, let's say we iterate one time, we'll be at node. Okay, so this one has 4 nodes. We already started at node 0, and then let's say we iterated twice, we'd actually be at the node at index 2, right? So we have to iterate to the correct node, and that's what that's a pointer is assigned pointer.next takes you to the next node. Oops. Okay, so that's what, so we start the pointer at the head. That's on line 40. And then we're going to iterate an index number of times. That's that loop at 41 does. Okay, so in every iteration, we're going pointer is assigned pointer.next. That means we go to the next node in the linked list, right? Pointer, I don't know if this drawing helps or not. Remember, this is next. So if pointer is like at C, then this, so the one right after, that's pointer.next. Not sure my writing isn't so good here, but yeah. So if C is pointer, the one containing E is pointer.next. And so that's all we're doing here. We're just going pointer. Yeah, this is the classic way of moving through a linked list. Pointer is assigned pointer.next. And that takes you to the next node of the linked list. So and then when you're done, we'll be at the exact node that we want to be, right? Because we're going to iterate an index node. So let's say index is 3, we would actually iterate 3 times, and we would actually be at node 3. Because remember, the first node is node 0. So if index is 0, 0 less than 0 is false, we would never iterate. If index is 1, we iterate exactly 1 time, and we do pointer is assigned pointer.next 1 time. So that loop is guaranteed to put pointer at the node that we want to change. And now what we do here, this is kind of interesting. So we need to save the data that's about to be wiped out. So we'll go. So we created a temporary variable. We created a temporary variable and we called it temp, and that's what we're going to return. So now the method actually compiles. We're returning something of type E. Okay, so we save the item that's about to be erased, and now we're going to update pointer.item. Pointer.item is assigned the item that's in the parameter. Right, so in this case, this is the parameter. So we're assigning the parameter item, the one that's in the, up here in the parentheses, to get item. Okay, but we save the old value in temp. And so we're returning temp. So if for some reason we need to save the data that was just kind of erased or what, it's not gone forever. So in case it has to be used. So any questions on the set method? And of course we learn the most when we're writing code ourselves. And then okay, so we did set, we did get, so let's do, the famous contains method. The famous, so we're just going to do 2 more methods. So students, this is the thing that's interesting about linked lists, or I keep saying that thing, lots of interesting things, okay. But the one thing to know about a linked list, and the same thing for an array list, you can actually store null. The data, like this data that's being stored in a known object, can be null, just like an array list. And it doesn't actually have to be an object. Remember, null just represents a placeholder for an object. It doesn't represent an object in memory. Okay, so I have this what's called an look there on line 21. I found it on the internet. And it's an overloaded equals method. And I want to know if target and source store the same value. And if they're both null, I'm going to return true. If one is null and one is not null, I'm going to return false. And if they're both non-null, we return target.equals source. The thing that we want to avoid is, see, let's say if target is null, so this would actually cause, we wanted to see if we're going to consider the case where the target is the input value to the target is the input, is the data that's stored in the in a node. And then, so if we go something like this, target dot equals src. Let's say we go like this. Okay, so if target is null, we get a null pointer exception. Right, so null dot, you never want to go null dot. That's what going to cause your program to stop. And with that kind of like, oh my God, null pointer exception, where did this come from? Okay, so first we check, so we actually have to check if target is null or not. Okay, so so I'm going to assume, I'm going to use one return. So I'll assume that equals is false. I'll assume that target and source do not have the same contents. And then if the target is null, and then I check if the source is null. And okay, so if target is null, if the source is null, then flag is true, right? Then flag will be true. And then otherwise, and there I'm on line 27, otherwise, so this would be, so here we know, so we're in this block where it says if target is null. And then we said, oh, line 24, is source also null? We said flag to true, else, then this would be source not equal to null. We don't actually need this. Now we're comparing, see, this would compare null and non-null. So this is the case, source is not null and target equals null. Okay, so that's false. And we actually don't need that because we initialize flag to false. Okay, else. Okay, so now let's look at line 30. Okay, now we're going to assume the target is non-null. Okay, and so, and it doesn't matter if the source is null. You can actually pass null to equals, right? So null can actually be an input value to equals. And if you look at the way we write our methods, like for the person class or all these the few equals methods that you've written, we're checking to see if the input value is null. And if it is, we set the flag to false. So if your equals method is written correctly, so if the equals method is written correctly, target dot equals null is false. And it's the equals method that gives us that value. Okay, so here, if the target is not null, we just call target dot equals source and set that equal to flag. So, and then you just return flag. So it's all this work. So 23 through 2030, that's the code we need to add if we're going to allow the data that's stored in a node object to be null. Okay, so we have this overloaded equals. Overloaded means it has two parameters instead of just one. So now let's do the famous contains method. And I used to do this wrong, students. And basically, so it's just like an array. We've written like a contains method for an array. You know, let's loop through the array and see if this value, let's say if an integer array, we want to know if 20 is in there. So we loop through the array until we find, you know, we do some comparison. Oh, this ARR of 20, ARR of 30 stores 20, and then we return true. So here we're going to loop through the nodes, and if we find a match, we stop. Okay, so it's public Boolean hello contains item. I want to know if the link. I want to know if one of the link lists. I want to know if one of the nodes in the link list contains items. So I'll just get Boolean. Let's assume that it's false. So this is an exist. And so normally for, you know, if I want to use one return for an exist, is there at least one value of node that stores item? Just assume the answer is false. Start by assuming the answer is false. Assume item is not, okay. Assume item is not in the linked list. And then we'll write code to see whether, you know, that's a good assumption or not. Okay, so while, okay, and since we're gonna actually, it's just like for the get in the set, we're gonna have to initialize pointer to head, and we're gonna iterate through the linked list. And if we find a match, we're gonna stop the loop. But we're gonna have something like we did on like the set method. You start the pointer at the head, and then you iterate through the linked list by going pointer is pointer dot next. So that's the classic algorithm. Just start pointer at the head and just iterate. Pointer is assigned pointer dot next. So okay, so then we're gonna use a while loop now. So while, now how do we know we're at the end of the list? It's when pointer is null. So while pointer is not equal to null and not flag. Okay, so not flag means we have not if flag is false, not flag is true. Okay, so if not flag is true, that means we have not found it. So if flag becomes true, that means we have found it. We have found the node that contains the item. Let's just stop. Again, I just want to point out here, we know that we're at the end of a linked list. When we go to the next we go to the next node in the line, and it turns out to be null. That's how you know you're at the end. So and you can also use the size property too, to make sure, you know, you could count the number of your iterations and make sure you're not greater than size. Okay, so let's just do this. Okay, so now we're gonna have an if statement here. So we start pointer at the head, and I want to know is pointer dot item. Oh, we're gonna use the, oh, whoops, what happened here? Okay, I got so excited about using the overloaded equals method. So equals, and I'm gonna go ptr dot item, comma item. Remember, item is the input parameter. So if that's true, oh, shoot, I didn't want to write. Let me write it like this, students. Flag is assigned this overloaded equals method, pointer dot item, comma item. And let's get this out of the way. Let's return flag so it compiles. Okay, so a pointer is not equal to null, so we start at the head. Okay, so is there another node in the linked list? And if that's true, and we have not found our a node containing the specified item. Let's say like we have a linked list of strings and item is cat. We want to know if cat is in the linked list. Okay, so then what you have to do is, okay, you have to make sure in the loop, just advance. So advance to the next node. So we're going to advance to the next node in the linked list. See that what I have there at line 25, that's kind of like a for loop. That's like I++. That takes you to the next array, because we get the array elements are indexed by integers, right? So here, yeah, here you have to go, you want to advance to the next node, you have to go pointers, assign pointer to next. Without line 25, we're in an infinite loop. We never get past the head, right? Okay, so we go to an item and like here, I'm not sure if these drawings are helpful. Let's say we're looking for, let's say like, let me just erase all this. Okay, let's say we're looking for contains, so let's say we're looking for contains, let's say Q, right? So we start at the first one, flag is false. Okay, go to the next one, flag is false. Go to the next one, oh, flag is true. The flag gets set to true, so now your loop stops, right? Flag would be true, so you still would advance to the next node, but flag would be true, not flag would be false, and that would stop it. So that's all there is to contains. And I used to, oh, and I did this wrong. I still did. It shouldn't be E item, it should be object. Sorry. I remember when so we actually can put anything in there. It doesn't have to be an E object, it can be any kind of object. And if your equals method is written correctly, if it's anything other than an E object, you'll get false. That's how we've written our equals methods in our classes. Like if we write an equals method for a person class, we can compare a person object to like a string or anything, but the equals method should force it to return false. Okay, so now one more, and then I'm done here. And I think it's add first. And then maybe we'll just try this. I think I have some code to try it. Okay, so public. And here I'll probably ask you to do something like, similar to this add first. So we have code. So the add method for down here, which we did before, this actually adds at the end of the linked list, right? So, and it separates it, that's on line 82, it separates the code into two parts, or the case, we're going to store some more data in the linked list. Add is the only time you actually go new node. And add is the only time we should be going size plus. And so we add a new node, and then where do we put that new node in the linked list? So here, we always add it at the end of the linked list in the add method on line 82. So again, so there's a special case. Is the size 0 or is the size greater than 0 when we're adding? So we're gonna have to do the same thing here. Okay, so we can copy some of this code right here. So I'll do it here. Yeah, you're never supposed to do what I'm doing right now. And if you do cut and paste, you really need to double check to make sure everything is written properly. Okay. Okay, so if head is null, that means the list is empty. So when you put a new node in the linked list, it's both the first and the last. Say otherwise. And now what we're gonna do is we're gonna put the new node in the linked list. And I have the, make sure I do it the same way I did earlier. Yeah, I have my notes on my phone, sorry, yeah. Okay, so Okay, so now what we're, I'll draw a picture. So now we have this new node, and we're going to go node.next is assigned head. So this new node, the one after the, so we have this new node on line, we create line 20, and it's just kind of all by itself, and it wants to join this linked list. So it's saying, okay, well, the one after this new node is head. And now we're saying, oh, head dot previous is going to be node, right? And now we update head is going to be, whoops. We're going to update head. It's going to be the new, is this new node. And then let's not forget to, this is really critical. I hope I put in the last, oh, I did last time. We'll see. I guess well, I have this video here. I'll see. I uploaded the code, so I'll see if I put in the code that I uploaded. So yeah, this is critical. If you don't go, this is critical. We don't want to add nodes and have our size not tell us the exact number of nodes. I know sometimes I forget that. Let's just draw a picture and make sure this works, and then we'll just do a couple tests to make sure it works. So basically all I was doing here is, let's say I was going add first. So all I'd be doing is I'm creating some new node object all by itself. And I'm saying, oh, node.next is head. That would be A. I'm going to say head.previous. If it's the head, the previous would be null. But now I'm saying the one before the node containing A is Z. And then I reassign. I'm saying head now points to Z. So it's pretty easy to insert a new node at the front or the end of a linked list. I guess the challenge would be to getting familiar with this code. But do you have any questions, Jose? I know I'm kind of going fast, and you probably need to try yourself. Any questions?
No.
Okay, so let's just try this and see if it actually works. I know that it does, I think. So where am I? Let's see here. Okay, so here we have this linked list, and see, yeah, we declare it with the generic variable string, and we add cat, and we add dog, and we add one. So let's just print that out. And what we should get is, so we add cat, so dog would come after cat, so it would be cat dog, and then when you add one at the beginning, it should be one dog cat. So let's just print out, let's just undo this, we can see what happened here. So let me try that one more time. Okay, let's not do this right now. Okay, so we're going to print out, so we're going to display, we're adding dog, cat, and then one at the very beginning. So we should get one cat dog. Everything worked perfectly. The tension is building here. Yeah, one cat dog, all right. Okay, so the add first method I think works. Okay, and then and let's just let's see. Oh, I did something here. Oh, let's do a set. Let's do a set. Okay, so now we're going to change what's in position 2 to zebra. So dog would actually be at position 2. So now it should print out one cat zebra, and we're going to print. It should first print dog, right? We're going to print that line 22. We're going to print the value that was eliminated from the linked list, and then we're going to print out the contents of the linked list. Remember, set returns the data that was replaced. So we're overriding dog with zebra. So set will return dog. We're going to print that out. All right. So prints out dog because that was eliminated. And now the list contains one cat zebra, right? Because that's what we did here on line 22. We went to node 2 and replaced it with zebra. And now let's see if these contained methods work. So it should print out zebras in the list. So this should be true. Right? We just added zebra, and we eliminated dog, so this should be false. Okay, 4 is not even a string object, so this should be false. So okay, so let's see if this works. So we should get at the very end, true, false, false. If it isn't, I'm going to be kind of sad. Yeah, true, false, false. All right. Because what it's saying is, where's test? What it says is zebra's in the list. That's true because we just added zebra. Dog, we print out the contains, we get false because we just remove dog from the linked list. And it doesn't, 4 is not even a string. So, and that's it. So as I said, I will write an assignment. Maybe you'll do, maybe like do remove first. And I'll just have like maybe kind of a short assignment where you're not writing a lot of methods just to give you some experience. And then maybe we'll have another one after that. But do you have any questions on this or the programming assignment or the quizzes? I'm going to stop the recording. I'm going to stop the recording first of all.